Welcome to the viewers. And now we discuss and especially an important theorem if g dash z is equal to 0 everywhere, in a domain D, then gz must be constant throughout G. And must be constant throughout D. Now we have to prove this. We write to prove this result, we put here gz equals to u is the function of xy plus iv is also the function of xy. Then assuming that g dash z equals to 0 in D, we have for just simply calculating with variable x, ux plus ivx equals to 0, and in view of Cauchy-Riemann or shear equation, we also have uy plus ivy is equal to 0. Consequently, we get ux equals to uy is equal to vx equals to vy is equal to 0 at each point in D. Now ux and uy are the x and y components of vector grad u. At a given point in a specific direction is a directional derivative. And just shortly we say that's grad u, that is del u del x is a directional derivative of u. in that direction. In fact, ux and uy are 0 means, in fact, ux and uy are 0 means that grad u is always 0. That is, directional derivatives of u is 0. Consequently, u is constant along any line segment lying entirely within D. And it's clear, obviously, because del u del x equals to 0 and directional derivative 0. That means a line segment, that's a whole line, and u is a constant. If we consider del u del x 0, then u is must constant. And which constant it goes in the line segment that's entirely within the specific domain in the concept of the vector field. And such there is a finite number of such line segments joined end to end. So we find a real constant say A such that u of xy is equal to A throughout D. Similarly, v of xy we get similar condition, that is B. Therefore, so we can say g of z, that will be given in the form of uxy plus ivxy, that is A plus I into V at each point in D. So it is a constant, so entire field throughout gz must be constant. So we can prove this type of results in the form of a theorem. Now we end our discussions. If you like this video, like it, share it, subscribe the channel. Thanks for watching.